Okay, so we'll just come to the topic for today. And the last topic, what we have to discuss in the second unit is vernal equinox. Okay, the motion of the vernal equinox. So the moment, like the seasons, that's what we are going to discuss in the today's session. And with that, we'll wind up the topic, second unit, and we are good to go for the first internal exam, which is going to happen on the 21st of August. And notes for interview, as I said, you can read the textbook and my notes for second unit. First unit I have completely done, no, except that assignment I have to. It's done actually, but I have to post it. The second unit I have started writing, but it takes some another 2 to 3 days, I guess. Maybe by Monday, most probably I'll be uh, giving that notes. But in the meantime, anyway, it's there in the PPT as well as notes also, like from the textbook, you can read it. Okay. But in the exam point of view, I will precisely make what exactly needed in the exam point of view, and I will give it as a notes. But I request you all to take textbook apart from that and to read from the beginning, so that you will get some good idea in this topic. Okay. So basically, when we talk about this vernal equinox, uh, we'll come to this first. So you have like we are dividing the earth into two half, one like one exactly in the half we call it as equator, and above the equator we have a northern hemisphere, and below the equator we have the southern hemisphere, and there will be a north pole at the top and there will be a south pole at the top, right? So this is how we are describing, and okay, so there will be a like celestial equator, and there will be an ecliptic. So ecliptic is nothing but the plane in the orbital plane of Earth around the Sun. If you want a clear visual, you can see this. This is the ecliptic plane. So Earth revolves around the Sun in an elliptical orbit. The path or the plane that makes by this revolution, like with respect to the Sun, this is the plane. Okay, it is a plane. It is an imaginary path, you can say, uh, with the reference of this revolution with respect to the Sun. This part, which is being shaded in the slight green color, that is the plane which we are calling it as an ecliptic plane. Okay, so that is one thing, and uh, the Earth's equator. So Earth's equator is what we are exactly dividing the Earth, the sphere. The sphere, Earth is in the form of a sphere. So if you divide that sphere into exactly two half, you will be having a hemisphere over there. Okay. So like exactly two half, and the line that divides the sphere into two half, you are calling it as the equator, and above the equator you will be having the northern hemisphere, and down it is the southern hemisphere. Okay, so this division, this cross section, we call as equator. The exact of the middle line, there is a reference line which divides exactly the sphere into two half. We call let us imagine that to be our equator, and the uh, what is that? Uh, Ecliptic is the plane that lies in between the orbital plane of Earth around the Sun. So that is again an imaginary plane. You can imagine like this. Okay. So this is the plane which we call as ecliptic plane. Okay. Uh, Now, what do you mean by this vernal equinox? Vernal, okay, that we will come back again later. So if you see here, first thing is, as I said, if you're keeping this sphere exactly in this position, uh, and with respect to the Sun, there is a plane which we are calling as an ecliptic plane. But in reality, this is not happening. Okay, if the Earth would be like this in the exact straight vertical position, then of course there will be few every places from the North Pole to the extreme South Pole, the climate it will be exactly same throughout the year, which is not the reality. Few places, even the sun, like a few months, there won't be any sunrises, and few places there won't be any sunsets also. You know about Arctic Circle and the uh, Antarctic Circle, where the climates are extremely different. And if this should be the case, for example, if this is the case, of course, everywhere you will be getting the same sun's radiation. Even the extreme tip of the North Pole and the extreme tip of the South Pole, like everywhere you will be getting equally the time duration of the sun, equal periods of the sun, day and night. But that is not the reality. Certain things are different. Why? Because is our uh, our globe or the sphere, which we call as the Earth itself, is not in this direction, which is slightly tilted at an angle of 66 degree with respect to this ecliptic plane. Okay, which means like from the axis of the Earth, it is nothing but 23 point. From the if you consider this as the reference, if you consider this to be your reference, then it is 23 and a half degree, which is tilted. So with respect to the ecliptic plane, it is 66 and half. Okay, so this understanding you just keep in mind. So now because of this, what happens is like few like what to say? Well, since it is tilted towards the sun, so sun is over here. Some part like when it is been in this position, uh, the northern pole will face more to the sun, whereas the southern pole does not face us to the sun. But when this revolve and comes to the right side, at this side, okay, if the Earth revolves and come to the other side, the same thing happens in the opposite direction. Because that time this inclination will be like this, right? And just opposite side it will be. So what happens is like the other side will be like having more sun's view, and like this side there won't be any sun's view. Okay, so this is the reality, and we'll again further proceed with that. So anyway, the Earth is revolving around the Sun with this tilted orientation. Throughout the revolution, it seems to be tilted like this. But again, the reality is every year there will be a slight variation in this tilt, and scientists have identified that the tilt is slightly decreasing year to year, and like wow, like now the recent observation is around 40 inches every 100, like 1 century, maybe 100 once in 100 years, there will be a drift of some small variation. It is decreasing. The tilt is decreasing, which means maybe because of the like other planets are also revolving because of that gravitation, or mainly because of that. So some changes have been happening in the system, and that has to be also considered when you do some calculation for a upcoming like some for example, like when we talk about some after 200 years, 300 years, some calculation if you're making in the space, you need to consider all these into your considerations. Okay. So that is one thing. So now, what do you mean by this vernal equinox? Okay, so before that, we'll go to equinox and solstice. Equinox is nothing but where the ecliptic intersects the celestial equator. Okay, so you know what is the equator, you know what is the ecliptic, the path of the like I have shown you the ecliptic path in a like which is more easy to analyze than this, the plane you have analyzed. So it has at some point it intersects the celestial equator that we call as equinox, and solstice, the ecliptic is farthest from the celestial equation. It will be in the far position. Okay, so with respect to this equinox and solstice, we are we our seasons are being made, and vernal equinox. Vernal means spring. Equinox means equal. Equinox means equal. Equal. So spring equal. We'll come back that to the next stage. So vernal equinox, two moments in the year when the sun is exactly above the equator, and the day and night are of equal length. That's why, since the day and night are of equal length, we call this as equinox. And to happen this, the sun is exactly above the equator. So as I said, we have a equator that divides the sphere, and above we have a northern hemisphere, and below we have southern hemisphere, and above the equator. Okay, that will come again. So this either of the 2 points in the sky where the ecliptic and the celestial equator intersects, we call this as vernal equinox. And in the northern hemisphere, the vernal equinox falls about March 20 or 21st as the sun crosses the celestial equator going north. In the southern hemisphere, the equinox occurs on September 22 or 23 when the sun moves south across the celestial equator. According to the astronomical definition of the seasons, the vernal equinox also makes the beginning of the spring, because generally for we will calculate this as a reference. Will start from March, where the spring season starts. Okay, so it will be from March 20 or 21 in the northern hemisphere. So that we will take as a reference mainly, uh, which lasts until the next summer solstice, June, from March 2021 to June 2021 in the northern hemisphere. And at the same time, in the southern hemisphere, it will be December 21 or 22 in the southern hemisphere. Okay, I hope you might have not able to assume or analyze in this online session, but again, the upcoming slides I have brought some things that maybe illustrate you exact positions. Okay. So the March equinox, which is nothing but the vernal equinox, marks the sun's crossing above the Earth's equator, moving from south to north. Okay, it happens on either March 20 or in basically we will fix it. It's on March 20. So March equinox marks the beginning of the spring in the northern hemisphere, and at the same time there will be autumn in the southern hemisphere. No matter where you are on the Earth, the equinox brings us a number of seasonal effects noticeable to the natural events around the globe. Okay, so what I exactly want to tell here is there's two things you can able to assume. One is the Earth revolves with a tilt of 23.5 with respect to this thing, and okay, so now I think this will be the better illustration for you. So at one point, let us say the sun is over here, and this is the north pole, and this is the south pole. So the Earth is tilted with respect to the ecliptic plane. It is 65-degree tilted, 66.5-degree tilted, and the north pole is facing the sun, where the south pole is away from the sun. Okay, this position you can assume. So let us say the sun is in the left and the earth is in the right hand side, which is the
Sir,
yeah.
so you are saying about elliptical orbit, right? Earth's
Yes, yes.
elliptical orbit is 66 degrees from the plane of sun's planar orbit, or what you are saying?
Uh, can you repeat it again?
So sun has a plane, right? Suns will
Sun
have
has a
different plane. Sun will have a plane, right, in which it is being rotate. Sun
uh,
will have a plane, and Earth
I,
will also have a plane. What is the angle
yes,
between
yes,
it?
yes. Yes, yes. We are concentrating only on the plane that makes the revolution of the earth with respect to the sun, not with the sun's because again the problem is with respect to the reference. We are considering a fixed coordinate system over here with respect to the stars. uh, that is advantage that star is giving to us, because when you talk about, if you don't have a fixed coordinate system, everything is we cannot assume anything here. By good thing, the stars are too far away from us. At least we have a fixed coordinate system, and with respect to that, we are able to say something where the planets exactly are with respect to some stars. So here, what we are exactly talking about is this one. Irrespective of the sun, because when you compare the sun's shape, it is very huge with respect to the sun. When compared to the Earth, the sun is very huge. So this plane is nothing but the revolutionary plane that the Earth makes with respect to the sun. That's what we call as an ecliptic plane. You can see here.
Saying, sir, you are saying that the ecliptic plane is a plane where sun and earth lies in one plane.
Uh, uh, yes, you can consider like that.
Okay.
You can imagine like that, because irrespective of the because when you assume sun's plane, but with respect to what, uh, we are assuming a plane with respect to the earth rotation, earth revolution around the sun. Similarly, as you said, the planes are like imaginary. It is based upon our imagination. You can imagine n number of planes also. But with respect to with respect to many things, you can imagine the planes. Is it confusing?
No. And
Okay.
you are saying that the CGs of both sun and earth will be lying in the same plane of the one which we call it as elliptical plane.
Uh, you can see this as an you can see this diagram. See here, this plane, exactly what I am telling as the ecliptic plane, is this is the plane which makes with respect with, because this earth revolves around the sun in this orbit, and while happening this revolution, there will be a plane with respect to the sun, and that plane is what I am meaning.
Sir, can you repeat it again once?
Okay.
No, sir, the sentence which you told right now. Can you repeat it again?
Yeah. Like for example, let us say Earth is revolving around the sun, right? Earth is revolving around the sun in an elliptical orbit. So when it revolves, there will be a path for its revolution. That's what we call as orbital plane, and that orbital plane with respect to the sun. You can imagine, you can extend, you can further, in a 2D, you will tell that this is the path, this path you call as orbital, that is the orbit. You call it as an orbit, which is an elliptical orbit. That orbit, if you further extend as a plane, or you extend it as a plate, to the sun, okay, to the sun. That is exactly what we call as ecliptic plane. So this is
Sir,
the exact illustration
excuse me,
for
sir.
it. Yeah,
Sir, excuse me, sir.
yeah.
Sir, I hope you, if I'm not wrong, I hope he's asking about what is the inclination of the sun, sir. So, like as you said, this ecliptic plane is with respect to the sun, but we don't have a greater celestial body to take reference for to form a plane with which we set an angle for the inclination for sun, no, sir. So basically, sun is the x-axis or horizontal, and we can only say the Earth, the inclination of Earth with respect to the sun.
Sorry, I didn't get you. Inclination of?
Sir, he's saying that my
Yes,
question is actually the sun's orbital CG will be different. I mean, so sun's plane will be different because it also rotates around
Yeah,
itself
yeah.
and it
It,
also
it, it,
moves.
it also it also rotates and it also revolves, but we are not considering. We are not
Yeah,
considering
yeah,
that.
yeah. Then another one is I'm
We, we,
saying
we are considering that it is fixed, because for our fixed coordinate system, we because that is its speed and as well as the revolution speed is very less when compared with our earth revolution and rotation speed with respect to the sun. So we are basically we are trying to fix that as a fixed system, sun's rotation as well as revolution.
So my question is, the orbital Earth plane will have some inclination with the sun's plane, right? So sun's CG plane. I'm asking what is that inclination? Not the
uh, this one you are asking, right?
yeah, sir.
60, this earth is tilted 23 degree off.
No, sir. The eccentric is it will have some eccentricity which is in elliptic orbit, right? But it might have some orientation, different orientation only, right? All the planets will don't have the same orbital plane with sun, right? So there will
Yes,
have different
yes,
orbital planes.
different.
They'll be somewhat higher in the plane and somewhat lower in the other planes. Some planets.
Of
That's
course,
what
of
I'm
course,
asking.
of course, of course. There will be different planes like this. For example, we are considering only for Earth. This is just an imaginary. There is nothing to be in reality. There is nothing like this. This is for our reference. We are considering an imaginary plane with respect to the sun like this. Similarly, if you consider some other planet, there will be with respect to the sun, there will be again some planes like this.
Okay, sir.
No, actually, I think something I couldn't give it over there or like.
Also understood, sir. Understood.
Yeah,
Understood.
yeah. We will discuss again. I think something more in like in person we can discuss more in that point. I think.
Okay, sir.
Yeah. So like yeah, where we stop, I think. Yeah. So this is again this is the plane of this inclination angle will be 66 degree with respect to the ecliptic plane. And if you see this, the north pole is concentrated more with respect to the sun, whereas south pole it is away. So let us imagine that Earth is to the right side of the sun, which is your apogee, right? So here in this shape, as I said, you there will be equator, and above the equator is the northern hemisphere, below the equator is the southern hemisphere, and there will be a point which is called the Tropic of Cancer, okay, and above the equator, and down there is Tropic of Capricorn. So let us say sun is just above the Earth's equator. It which means like sun's rays are exactly pointing in the equator. Okay, which will not be same throughout the 365 days, because Earth is also revolving in the tilted direction with respect to the sun. So what happens is like for example at the point it is exactly pointing like this. Okay, it is exactly pointing the equator. But when it goes on, like you can see here. So here this is January, February, March. So during March we can say exactly it is pointing the equator. So this will cause a season, right? And that will be, and at the same time, like the other side of the earth, like one side, we can say, uh, you can see this, the northern hemisphere during this March 20 to 21, this position, you can imagine this position, okay. Uh, this is March, and the sun is just above the equator, you can assume, and it is vernal equinox, whereas at the same time, in the southern hemisphere, it is autumnal equinox. Okay, so in like northern hemisphere during March, you'll be having spring equinox, and equinox. Why equinox again? You will be having equal day and night times during when the position of the sun is just pointing, or the subsolar point is exactly pointing the equator. Okay, you will be having equal day and night time. Okay, so northern hemisphere also, even though in the northern hemisphere you will be having spring, equinox, your day and night time will be equal over there. In the southern hemisphere, you will be having autumnal equinox, but your day and night time will be equal. That is the only reason you are saying it is equinox. Okay, and now what happens is the next it moves like this. It comes the next 3 months. It will it revolve and comes to June, let us say. Okay, so you can see this position. Similarly, this subsolar point also, it moves to the upside. Okay, from the equator. Earlier it was exactly pointing the equator. The subsolar point, again, how you are analyzing is like there will be different rays of the sun, but you are concentrating only on the subsolar point, which is a ray that is exactly matching with the equator. If you stand exactly in this position, this subsolar point is a ray of the sun, which does not cause any shadow, let us say, equally inclined with the equator, let us say. So, okay, so the next movement will be like it moves to the top. So since it is also rotating and revolving, it takes some 3 months, let us say. Slowly it will move to the uh, Tropic of Cancer region over here. And that will be the maximum limit where the subsolar point will move. After this limit, the subsolar point cannot move. Okay. Only up to this point where the subsolar point can move, we call as Tropic of Cancer. And after, why tropic? Again, tropic means from there it will take a tan. That's what we mean as tropic. So from the Tropic of Cancer, again the next 3 months, let us say the next 3 months, it will again come back to this equator position. Again, it will come to the equator position. Again, the next turn, it will this solar point will move down to the Tropic of Capricorn. Okay, and that will be the maximum point where this subsolar point of the sun will move. After that, again the season will proceed further. So this point in the subsolar point, when it exactly matches with the equator, is on the day of March 20 to 21. Mainly it is calculated as March 20, and that day will be the spring in the northern hemisphere and autumn in the southern hemisphere, right? So you can see, and again the movement will vary. It comes over here. This subsolar point will move above. When it comes to the July, the subsolar point will move to the, you can see here, it is in the Tropic of, where it is, yeah, it is in the top position, Tropic of Cancer, right? And the season you can see here. That time it will be in the northern hemisphere. It will be June. So summer will be there in the northern hemisphere. At the same time, the other southern side, downside, down from the equator, you will be having the southern hemisphere where there will be winter, because sun's entire sun's radiation will be focusing at the top. Here it will be cool over here. So here it will be winter, and the top northern hemisphere will facing the summer. Okay, and the next again it will come back to the equator position. So that time you will be having the other two regions will be this will interchange. Like northern hemisphere will get autumn and southern hemisphere will get spring. And again the next movement, the subpolar point will come to the bottom Tropic of Capricorn, where you will face winter in the northern hemisphere, because sun's energy will be pointed over in this direction. Here there will be less sun's radiation in the northern hemisphere. So that time the northern hemisphere will face what is that winter, and southern hemisphere will face the uh, summer. But now again one more thing is there called two regions here called one is in the North Pole and one is in the South Pole. There are two circles called Arctic Circle and Antarctic Circle. Here, the problem is, I think you can assume from here. Uh, yeah, if you see this, because of the Earth rotation, Earth rotates within 24 hours. Earth rotate with respect to its axis, right? So in this axis, since the 23-degree tilt is there with respect to the or with respect to this, there is a tilt of there is an angle of 66 degree. What happens is, when the northern hemisphere is facing towards the sun, okay, you can say when the northern hemisphere is facing towards the sun, and the the sub subpolar point is in the tropic of Capricorn, let us say. Okay, the sun's radiation is more in the northern side. In the tropic of Capricorn, you have the subpolar point. So that time, what happens is the rays of the sun at the top in the Arctic Circle, you will be having the 24 hours day, because I think some animation I had it, I couldn't play it over here. Every time, like here the sun's rays, the top, but it won't be that hot, but the least ray of the sun will be always present over the Arctic Circle. Every time, 24 hours, it will be light in this season. Again, when the in the same position, when it comes to the when the subpolar point will come to the topic of Capricorn, down. Similarly, the opposite will happen. Here it will be sunlight, and here it will be dark. So what happens is the time when this topic Arctic Circle is fully day. At the same time, in the Antarctic Circle, the sun's radiation cannot pass through. This region will be entirely away from the sun because of the tilt. This Antarctic Circle cannot, sun's radiation cannot enter into that region of the Earth during that period. So what happens is there will be 24 hours night, and again when it changes to that side, right side, the vice versa will happen. So that is why it is very difficult to have a life in this Arctic Circle and the Antarctic Circle. Okay, so you can just see this. So winter, your where is that March will start from March. So this is your spring equinox. It starts from 21st March, and the moment you can see, this is the like from when you have spring in the northern hemisphere, you will be having winter, sorry, autumn in the southern hemisphere, and when you have like in the northern hemisphere, when you have summer, there will be winter in the southern hemisphere. Similarly, like these two were not. So where are they? Yeah, spring and autumn. Like during this time, like the day and night will be exactly off during autumn and spring, because the subpolar point, the subpolar radiation or the subpolar point of the sun's radiation is exactly falling in the Earth's equator, or we can say sun is just above, exactly pointing towards the Earth's equator. So during these two times, you will be having exactly equal daytime and equal nighttime, whereas the other two we can't say, because of the few places will have a different, and other few places will have a different situation, and few other places will have a different situation. Okay, so uh, so I think with this we will end up today.